Hey, this is a video for 1.6, the phosphorus cycle. So go ahead and check out the overview and set up your guided notes. So phosphorus is a very important limiting nutrient because phosphate is very important. Phosphate is found in ATP. ATP is the abbreviation for adenosine triphosphate. And every time one of these phosphates is removed from the ATP molecule, it provides a lot of energy for cellular functions. So you've heard ATP used synonymously with the term energy. This is why, because when these bonds have very, very high levels of energy. So all of the life functions require this ATP. But also, DNA and RNA have phosphates as part of the backbone of DNA. So these little yellow circles this is very, very simplified, but phosphates are required in order for the structure of DNA. So phosphate is very important. The other thing, it's a very slow cycle, and there's one other thing to remember is phosphate it only has a solid component. There is no gaseous phase of the phosphate cycle. The phosphorus cycle, it's literally phosphate moving slowly because it's basically in rock in solid form. So first thing that happens is phosphorus will weather off of rocks from weathering, and that can make smaller and smaller particles. And then the phosphorus can run off in the form of phosphate into a body of water or into, be picked up by organic material. When it runs off, it can leach, and leaching is kind of like when something soaks in. Like leaching is like if you get your book bag wet and the ink from your pen in all of your papers like starts running through the paper. That's kind of what leaching is. It's when the substance is carried through water. And then when it is leaching, it can be picked up or assimilated by these plants in the form of phosphate. Now the phosphate that runs off can go deep down into the bottom of the body of water, into the benthic zone, and this is a process called sedimentation. And again, this takes very, very, very long time. And after sedimentation, you can have uplift, much like we saw in the carbon cycle. So again, most of this is happening through the movement of phosphate, which is PO4. Now, humans can have an impact on the phosphorus cycle. For example, when we're mining for phosphates or when we increase phosphates in the ecosystem. When we're mining for phosphates, we're really trying to get that for organic or inorganic fertilizers. And then that phosphate is obtained from the rocks. But also when that phosphate is used in agriculture, it can increase phosphate in the ecosystem. And this runoff occurs because not all the fertilizer has been absorbed. Now this can lead to biodiversity loss because of the phosphate mining, because we are destroying habitats. And the increased phosphorus in the ecosystem can lead to eutrophication, which is, eventually reducing the amount of oxygen that's present in the water, and that can lead to biodiversity loss in the form of dead fish. So this is very short and sweet. What I would like you to do is to respond to this check for understanding. And now for the FRQ practice. I want you to explain how the use of phosphate fertilizers can contribute to eutrophication. I hope that this video is informative. I thank you for your attention, and I will see you soon.